All right, in this video, we're going to investigate the shape of a normal distribution. We're going to use the Desmos website or graphing tool called the graphing calculator. And so we're going to investigate the normal distribution. There are many different normal distributions, but they all are very similar. And what characterizes each is the population mean and population standard deviation. So here I'm going to go ahead and graph the standard normal distribution, which has a population mean of 0 and a standard deviation of 1. So a mean of 0 and a standard deviation of 1. And this is how it would look. And here you can see the graph here forming. I'm going to go ahead and adjust some settings here using this icon here. I'm going to get rid of the grid. And I'm going to scale the x-axis different. We're going to go from -4 to 4. And then I'm going to scale the y-axis from, say, -0.25 to no more than maybe, say, 0.8. Okay, so that should give us a nice view here. So this is the standard normal distribution. However, once again, they all differ by the mean and standard deviation. I'm going to use a little bit of algebra here. So in algebra, you would notice if you've taken algebra before, you might have studied something called transformations. And every other normal curve is basically a transformation of the standard normal curve, which is this graph here in red. So I'm going to use some transformations here to visualize other ones. All right, so there is we're going to multiply by a constant here, 1 over s, so 1 over the standard deviation, times the function, the standard normal curve evaluated at x minus the mean divided by s. Okay, and so what the mean, the m and s are going to represent are the standard deviation. So we see s represents the standard deviation and m represents the mean. Okay, so in other words, the mean is a horizontal translation, and s kind of reflects or stretches or shrinks the normal curve. So we're going to see how that happens. Let me just adjust some settings here. Since the standard deviation cannot be lower than is always greater than or equal to 0, I'm going to say that let it range from 0 to 2 in steps of, say, 0.01, for instance. And then the mean, we'll say, let it go from, say, -4 to 4 in steps of, say, I don't know, we'll say 0.1. Okay, so when we see here, the blue curve is representing the transformations or the shape of different normal curves. Okay, so the red one is the standard normal curve, which we'll see right now. They're exactly the same right now. And you'll see how different the other curves look compared to the standard normal curve. All right, so first thing is the mean. M is representing the mean. So if you notice, the standard normal curve has a peak above 0, right? And the ends of each normal curve taper off in both directions towards the horizontal axis. In fact, it never crosses it. And we call that a horizontal asymptote. Okay. So let's see what happens if I make the mean, say, go towards 1. What do you notice about the curve? What is it doing? You can see that the blue curve pretty much has the same shape as the standard normal curve, except now the mean is over m equal to 1, which represents the mean of that particular curve or that particular population. Okay, so then let's go ahead and drag it further to the right. You can see that as I move to the right, the peak stays above whatever the mean is. That is true also if I go towards negative, say, 2. You can see that the peak is now over -2. In fact, if you go all the way to -3, you can see that as well. But it still possesses the same shape. Okay, so what we notice is that the peak is always over the mean. But what about, and that makes sense, right? That makes sense because it would split the curve exactly in half, right? And what does it mean? It's the measure of center. So the measure of center is where it divides, the population, in this case, evenly, right? In other words, the mean and median here would be exactly the same because it would split it evenly. Okay, so what is S? S is the standard deviation, which is a measure of spread. How clumped the data is around the mean, or how dispersed from the mean it is. So I'm going to go ahead and change S and make it go towards 0, which would indicate that we have less spread. Let's see what we notice. Well, you notice as I'm going to 0, the peak is rising. In other words, things are getting more clumped towards the mean of 0. So a higher peak, and as you go towards 0, everything's getting towards 0. Now, of course, if I take that mean and go the opposite direction beyond 1, you'll notice that there's going to be more spread than the standard normal curve. So if I go to the right, you can see that the peak is actually dipping below the normal curve. And it's allowing for more spread among those x values. And that's what you notice. And I'm going to go ahead and play this so you can see it all happen at once. So once again, the red curve is the standard normal curve, and the blue curve is changing based on those parameters there. Okay, so that's the shapes of standard normal curves.